Have you ever gazed up at the serene, silent tapestry of the night sky and felt a sense of peace? It seems so tranquil, so unchanging, a vast dark canvas dotted with the gentle twinkling lights of distant stars. But what if I told you that this placid scene is a grand illusion? That beyond our fragile blue world, the universe is a place of unimaginable violence and chaos. A cosmic battlefield where forces beyond our wildest comprehension wage an eternal war. What if those gentle lights are not beacons of welcome, but warnings of places so dangerous, so utterly hostile to life, that to even approach them would mean instantaneous and absolute annihilation? What are the most dangerous places in the universe? This is not a journey for the faint of heart. We are not merely sightseeing among the planets of our quiet solar system. Instead, we are venturing into the heart of darkness, to the very edges of physical law. We will visit places where gravity is so strong it tears the fabric of space-time itself, where stars collapse into objects so dense a single teaspoon would outweigh a mountain, where explosions release more energy in a single second than our sun will in its entire 10 billion-year lifetime. These are the cosmic nightmares, the universe's own torture chambers, where the rules of our everyday existence simply do not apply. They are the ultimate cosmic perils. Our journey begins where light itself goes to die. We will stand at the precipice of infinity and stare into the abyss of a black hole. From there, we will travel to the crushed remnants of dead stars, spinning with terrifying speed and emitting lethal beams of radiation. We will witness the universe's most powerful explosions, capable of sterilizing entire galaxies from light years away. These are not science fiction. They are real, observable phenomena. They are the monsters that lurk in the cosmic deep, the ultimate expressions of nature's power. They are waiting for us in the profound, silent darkness between the stars. So, steel your nerves and prepare your mind. We are about to embark on a grand tour of the most terrifying destinations the cosmos has to offer. We will confront forces that can bend light-shatter planets and erase matter from existence. This is a voyage to understand the sheer scale and power of the universe. For all its breathtaking beauty, it is also a place of profound and absolute danger. The quiet night sky will never look the same again once you know what truly lies beyond its veil of peaceful starlight. Let us begin. Our first destination is perhaps the most famous and feared object in the entire cosmos, the black hole. Imagine a region of space where gravity has become a tyrant, an absolute monarch. Not even the fastest thing in the universe, light, can escape. This is a black hole. It is not a hole in the traditional sense, but rather an immense amount of matter squeezed into an impossibly small space. It is the ghost of a massive star, a final collapsed state of matter that warps the very geometry of the universe around it. It is the ultimate prison, a one-way trip to oblivion. Picture yourself in a spacecraft, drifting closer to one of these cosmic enigmas. From a safe distance, it appears as a perfect sphere of absolute blackness, a hole punched in the fabric of the cosmos. The stars behind it are not simply blocked, their light is bent and distorted, creating a strange gravitational lens effect, a halo of warped starlight around the edge of the void. This boundary, this point of no return, is called the event horizon. It is not a physical surface you could touch, but a threshold. Cross it, and your fate is sealed. No engine, no force, no power you can conceive of could ever pull you back. What would happen if you were to fall in? As you approach the event horizon, a strange and terrible process would begin. The immense gravity of the black hole would pull on the part of your body closest to it more strongly than the part farther away. This differential pull, this tidal force, would stretch you. It would stretch you and stretch you, elongating your body until you were a thin stream of atoms, a process that physicists, with a touch of grim poetry, call spaghettification. You would be drawn out into a noodle of matter, miles long before being pulled across the event horizon and into the singularity. Once inside, all bets are off. The known laws of physics break down at the singularity, the infinitely dense point at the heart of the black hole. Time and space as we understand them cease to have meaning. Would you be crushed into an infinitely small point? Would you emerge into another universe? We simply do not know. The black hole is the universe's greatest secret keeper. It is a place where matter, space, and time are pushed to their absolute limits and then beyond, into a realm of pure mystery from which no information can ever return. Leaving the silent, all-consuming darkness of the black hole, we venture to a different kind of extreme object, the neutron star. If a black hole is the ghost of a truly massive star, a neutron star is its hyper-dense corpse. When a star several times more massive than our Sun runs out of fuel, it collapses under its own immense gravity. The resulting supernova explosion blasts its outer layers into space, but the core implodes with such violence that protons and electrons are forced together to form neutrons. The result is an object of almost unbelievable density, a city-sized sphere with the mass of 1.5 suns. Imagine trying to comprehend this density. A single sugar cube's worth of neutron star material would weigh about 100 million tons on Earth. That is the weight of the entire human population, squeezed into a space you could hold in your hand. The gravity on the surface of a neutron star is about 200 billion times stronger than Earth's. If you were to somehow approach it, you would be flattened into a subatomic smear on its surface before you even got close. Any object, from a spaceship to an asteroid, would be instantly obliterated by these tidal forces, torn apart and added as a thin veneer to the star's already incredible mass. Many neutron stars are also pulsars. As the parent star collapsed, its rotation sped up dramatically, just as an ice skater spins faster when they pull their arms in. Some neutron stars rotate hundreds of times per second, faster than a kitchen blender. This rapid spinning, combined with an incredibly powerful magnetic field, trillions of times stronger than Earth's, creates a terrifying spectacle. The magnetic field funnels particles into powerful jets of radiation that blast out from the star's magnetic poles. As the star spins, these beams sweep through space like a cosmic lighthouse. If one of these beams were to sweep across our planet, it would be catastrophic. The intense flood of X-rays and high-energy particles would strip away our atmosphere, boil our oceans, and irradiate the surface, rendering Earth completely sterile. These are not gentle pulses of light. They are relentless, high-energy death rays, sweeping across the galaxy with clockwork precision. The neutron star is a stellar remnant that is anything but dead. It is a cosmic crusher, a spinning, magnetic dynamo of immense power, and a testament to the extreme states matter can assume in the universe. Of all the sudden, cataclysmic events the universe can muster, few are as terrifyingly powerful as a gamma-ray burst, or GRB. These are the most luminous and energetic explosions known to occur in the cosmos, flashes of intense gamma radiation that briefly outshine entire galaxies. For a few fleeting seconds, a single GRB can release more energy than our Sun will produce in its entire 10 billion-year lifespan. They are the universe's ultimate death rays, focused beams of pure destruction. We are on a grand journey. It's honestly pretty terrifying staring into the face of the universe's most extreme creations. Like this essay and subscribe to our channel so you don't miss the voyage. Imagine looking back across billions of light years to the dawn of the universe. In that ancient cosmos, you see points of light that are not stars but entire galaxies. At the heart of many of these young galaxies, a core blazes with the light of 1 trillion suns, outshining all the stars in its own galaxy. This is a quasar. At its heart lies a monster we've met before, a supermassive black hole. Not a few suns, millions of suns, even billions of suns. The accretion disk is the true engine of a quasar's power. The disk becomes a cauldron of superheated plasma glowing insanely bright. Many quasars also launch colossal jets of matter and jets of energy stretching hundreds of thousands of light years into intergalactic space. To approach a quasar is to fly into a cosmic furnace. Long before the black hole, you'd be vaporized by radiation pouring from the disk. The light exerts radiation pressure, acting like a sandblaster, tearing ship and body apart atom by atom. It is the brilliant, the blazing, the utterly lethal heart of a violently young galaxy. For most of its life, a massive star is a balancing act. The outward pressure of nuclear fusion, creating light and heat, perfectly counters the inward pull of its own immense gravity. But this balance cannot last forever. When a star at least 8 times the mass of our Sun exhausts the fuel in its core, fusion ceases. In an instant the balance is broken, gravity wins, and the core collapses catastrophically in a fraction of a second. The outer layers of the star then come crashing down and rebound in a titanic explosion. This is a supernova. The spectacle is one of the grandest in the cosmos. For a few weeks, the single exploding star can outshine its entire home galaxy, releasing a blast wave of energy and matter that rips through the surrounding space. The explosion forges new elements: gold, platinum, uranium. It scatters them throughout the galaxy. The iron in your blood, the calcium in your bones. It was all forged in the heart of a star and scattered across space by a supernova explosion billions of years ago. But what if you were to witness this event up close? Say your spacecraft was orbiting a planet a few light years away from the star, about to go supernova. You would have no warning. The first sign would be a blinding flash of light and an incredible surge of neutrinos. Hours later, the high-energy radiation arrives, gamma rays, X-rays, a deadly wave that would obliterate the planet's atmosphere and sterilize its surface. Then comes the main blast wave. Weeks later, months later, or even years later, the expanding shell of the star's own material would slam into your system. Traveling at millions of miles per hour, this tsunami of superheated gas and dust would be like a physical wall, scouring planets of their atmospheres, vaporizing oceans and blasting their surfaces bare. There are stars so colossal, so titanically massive, perhaps more than 100 times the mass of our Sun, that their death makes a standard supernova look like a mere flicker. When one of these behemoths dies, it produces an explosion of such mind-boggling violence that it has earned a name to match its scale: a hypernova. These are the most powerful explosions in the universe since the Big Bang itself, which then launches two incredibly powerful focused jets of energy out of the star's poles. A hypernova's effects could be felt across hundreds of light-years or even thousands of light-years. If a hypernova were to occur on the other side of our galaxy and its gamma-ray jet happened to be pointed directly at Earth, the results would be utterly catastrophic. The very existence of hypernovae serves as a stark reminder of the sheer violence of which the universe is capable. These are not subtle events, they are galactic-scale cataclysms. A hypernova is the ultimate stellar death, a final defiant roar from one of the universe's true giants. We have journeyed to the edge of reality and stared into the abyss. We have visited the crushing gravity of neutron stars, dodged the sterilizing beams of gamma-ray bursts, witnessed the galaxy-shattering explosions of supernovae, hypernovae. We have seen that the universe, for all its serene beauty, is a place of profound and unimaginable danger. The quiet, peaceful night sky is a lie, a beautiful veil that conceals a cosmos filled with monsters. Yet in this terror, there is also a deep and profound beauty. To look up at the stars is to see both the cradle of life and the furnace of annihilation. They challenge our understanding, they inspire our awe, and they fuel our unending quest for knowledge. The cosmic nightmares are out there, but so are the wonders, and the journey to understand them has only just begun.